So let's move on to question number 12. A body moving with a constant acceleration travels the distance 3 meter and 8 meter in 1 second and 2 seconds. So two scenarios are given. In first scenario, t1 is equal to 1 second. In this case, t2 is equal to 2 seconds. In first case, the distance traveled is 3 meter. In the second case, the distance traveled is my laptop battery was about to die, so I paused it for a second. In case 2, the distance traveled is 8 meter. So let me write that down. Distance traveled is 8 meter. And we know that we need to calculate many things: initial velocity, acceleration, something, something, something. So let's look at the formula. It is either v square is equal to u square plus 2s because s is given, but in this case t, there is no mention of t. So then let's look at the formula. S is equal to ut plus half at square. So for this case, let's look at this. S in this case is 3. So 3 is equal to u, we're not given. Time is 1 plus half into a, not given, time 1, so 1 square, which means 3 is equal to u plus half a. Taking LCM, 3 is equal to 2u plus a upon 2. Cross multiplying, 6 is equal to 2u plus a. This is an equation that we get. This is the first equation. Let's look at this. In this case, it will be 8 is equal to u multiplied by time, which is 2, plus half into acceleration, we don't know, time 2, which is 2 square, which is 4. So this is 8 is equal to 2u plus half into a into 4. This is 2. So 8 is equal to 2u plus 2a. This is my second equation. Now we need to use simultaneous equations to solve this. Well, we haven't done, I don't think you've done simultaneous equations yet in mathematics. It'll come in some time, but let me just tell you a small trick how to solve simultaneous equation. To solve it, you need to ensure that one of the variables, in this case, we have two variables. U is a variable and A is a variable. And here also U and A, two variables. I need to ensure that I either add or subtract in a manner that one variable is cancelled. So let's look at this in any case. So 8 is equal to 2u plus 2a. Let's subtract the first equation from this, which is, so let's subtract. This will be is equal to 2u plus a. When I subtract, the sign gets opposite. So this becomes negative, this becomes negative, this becomes negative. So 8 minus 6 is 2 is equal to 2u minus 2u gets cancelled. So it's 0, and 2a minus a is a. Therefore, a is equal to 2 meter per second square. I've got my value. A is equal to 2 meter per second square. I'm repeating, to solve a simultaneous equation, you need to ensure that one variable gets cancelled. So for that, you will have to either add or subtract. In this case, since 2u and 2u are same, I subtracted them so that u gets cancelled. I'm left with one variable. Now let's put, now that we know one variable, put a is equal to 2 in, let's say, equation 1. And what do I get? 6 is equal to 2u plus 2, which means 6 minus 2 is equal to 2u. Therefore, 4 is equal to 2u, which means u is equal to 4 by 2 is equal to 2 meter per second. So the initial velocity is 2 meter per second and the acceleration is 2 meter per second square. Let's move on to question number 13. Question number 13. Question number 13 says a car travels with a uniform velocity of 25 meter per second for 5 seconds. Perfect. The brakes are applied, the car is uniformly retarded and come to a rest in 10 seconds. So let's try and draw what I know. This is traveling at a 25 meter per second. So this is, the speed here is 25 meter per second and this is for 5 seconds. And then the brakes are applied and then the car is uniformly retarded and comes to rest in further 10 seconds. So for the next 10 seconds, the speed of the car is reduced. This is 10 seconds. At this point of time, brake is applied. Right? So at this point, brake is applied, and then it comes to rest in 10 seconds. So the question is the distance which the car travels before the brakes are applied. So before the brakes are applied, what is this distance? Well, since it's a uniform velocity, I know speed is equal to distance upon time, which means distance is equal to speed into time, which means speed is 25, time is 5, so the speed is 125 meter. Done. Part 2. Part 2 is calculate the retardation. So for retardation, I know the formula is acceleration is equal to final velocity minus initial velocity upon time. In this case, the initial velocity is given as 25 meter per second, and it comes to a rest, which means final velocity is 0, and the time taken for it to come to a rest after brake is applied is 10 seconds. So then this will be equal to 0 minus 25 upon 10, which is equal to negative 2.5 meter per second square. Now, since the question is asking me for retardation, I will have to write the answer as retardation is equal to, not negative, retardation will be 2.5 meter per second square. But if I have to write it as acceleration, it will be negative 2.5 meter per second square. And then the last part, the distance traveled by the car after applying the brakes, which means after applying the brake, what is this distance? So I have two formula, v square is equal to u square plus 2as, or s is equal to ut plus half at square. Whichever one I can apply, I have s is equal to ut plus half at square. Let's apply this. Initial velocity is 25, time taken after applying brake is 10, plus half into acceleration. Acceleration is negative 2.5, time is 10, so 10 square is 100. To 1 to 50. So this is 250 plus multiplied by minus is negative. 2.5 into 50 is 125. So this will be equal to 125 meter. Let's see if I have time to solve the last part of this question.